Ďakujem veľmi pekne za slovo. Nebudem prezentovať tentokrát ja, len chcem v krátkosti veľmi vysvetliť, o čom bude naša prezentácia. Pôvodne sme mali prezentovať systém Flare IQ, čo je jeden z najpokročilejších produktov výrobcu PANAMETRICS a je špecificky určený pre prevádzku poľných horákov, čo sa týka najmä Slovnaftu. A keďže o tému bol enormný záujem, podarilo sa nám, respektíve vyvinulo sa to tak, že zajtra je v Slovnafte samostatná akcia týkajúca sa len Flare IQ, kde budú zástupcovia z celej skupiny MOL pripojení nejakým online spôsobom, takže museli sme to a chceli sme to pre nich spraviť separátne. Tak som využil prítomnosť globálneho manažera pre prietok z Panametrixu a bude prezentovať opäť to, v čom je Panametrix výnimočný a prejde niekoľko netradičných a náročných aplikácií s produktami výrobcu Panametrix, čo sa týka prietoku. Gerard.
Yeah, thank you very much, Borislav, but I didn't understand anything. So, first and foremost, I must apologize because I'm among the only few in the room who doesn't speak Slovak. So you need to support my English with a French accent, right? So, this morning, Boris talked about the technology, the type of applications, but Panametrics was created in the 1960s. And since then, we have one focus as far as flow is concerned, is ultrasonic as a technology. So which means that we not do a lot, but we do one technology and we think we do it well. So I selected just about 10 applications. This one is on refineries, and this one features the EV residue applications. EV residue is a difficult application because it's heavy, it's crappy, and if you look at this one on the left-hand side, you see a coker. A coker is a deep conversion unit that takes the crap of the crap from a refinery. That's the bottom of the bottom, essentially. So most of the time, people are using, as you can see on the right-hand side, they use wedge meters. Because the wedge meters have a big advantage over orifice plates, is that they don't have impulse lines, because the impulse lines, they're going to clog very quickly. So they have the membrane or the seal that is in direct contact with the fluid, but everything else is clean going to the pressure transmitter. But it's still a very difficult one because they're going to clog the diaphragm. So we have replaced some of these on existing units by our systems. And nowadays, because it's so safety critical, it's seal designed. So it means that one of the flow meters will be connected to the control system to pilot the reaction, and the other three will go to the emergency shutdown. And the voting logic is typically 2 out of 3. So if you have 2 out of 3 out of order, you're going to trip. Trip means that you're going to close one of these lines feeding the furnace. In case you have typically 4 lines per furnace. If you trip one, that's still fine. If you trip 2, you need to completely stop the reaction. Otherwise, what happens? Boom. Explosion. Right? So this is really safety critical. So there are some others that have been used on the feed lines as well, that can be on the crude distillation unit, on the vacuum distillation unit, on the vis breaker. So everywhere that you have a residue. This other one is also something that you don't see on all the plants, but it's called the de-asphalting. So this one, if I'm fully honest with you, when we were asked to provide a solution there, we were not fully confident it's going to work. Because if you look at the viscosity, it's quite high. Normally, even though that's a Newtonian fluid, it's a very difficult application. So what we did, we reduced the frequency of the transducers to have this to work, and it works. This one is in Europe. That one is just to show that this picture on the right-hand side is from 1995. So, in other words, we were dealing with hydrogen even when hydrogen was not cool. Now it's very trendy because as part of the energy transition, but we have a lot of measurements in these applications on the hydrocracker. Now I go onto the petrochem industry. So what you have on the left-hand side is the steam cracker unit at the beginning of the chain. So you have the so-called quench oil. So quench oil doesn't seem very difficult. It looks like a diesel with some thin particles. And the issue is that they erode the orifice plates where they are installed. And we have had also using clamp-on, as explained by Boris this morning, on those lines, even though it's a fairly, I would say, medium temperature. So it works well and it's reliable. There's another one that is very new. This one was only tested in February of this year. This is also a special process unit that's called ethylene vinyl acetate, EVA. And you can see the pressure there of the line. That's a gas line, 195 megapascal. How much is it in bar? Speak up.
Almost 2,000.
Correct. That's 1,950 bar. So you can see the thickness of the pipe. It's not a big pipe, but it's 45 millimeters thick on the radius because of this high pressure. So again, that was a test, and it works. We don't see that very often, if I'm honest, but we learn every day. That's why I love this job. We learn every day, right? Now this is something a bit special that's called for paraxylene production, you have two mainline sensors. The one on the left is UOP, the one on the right is Accents. They have slightly different processes, but they struggle with one thing. What you have on the pump around, so if you look at the main adsorber, to produce xylene and paraxylene, they need this reaction to be fully controlled. And in case you have a change on the flow rate, you need a meter to react very quickly to maintain the product within specifications. And they were using turbine flow meters. Turbine flow meters are extremely accurate and extremely repeatable, no doubt. However, because they have mechanical spinning and bearings, they drift over time. So the consequence of this drift is that you finish to get the product out of specs, and then you need to scrap it. So they have changed those flow meters using custody transfer type ultrasonics to maintain the reaction within good conditions. Now we talk with ammonia, so phosphate or fertilizers or whatsoever. Ammonia is also a good vehicle for hydrogen, if you look at the molecule. But here, these are the kind of applications that we have. You can read for yourself. I'm not going to go through them, whether it's liquid, whether it's gas. I know I just noticed I'm a bit over time, so I accelerate. This one is from the steel industry. So Anton and Boris are very well involved in the steel plant in the country. This one is not very well known because it's a byproduct of the steel plant, so it gets out of the coke oven system, and it's called tar. It's a liquid. It looks like bitumen a little bit, and this is also a measurement that works very well with ultrasonic, and we have several that are installed. Here I switch to power generation. So Boris this morning mentioned that the system can measure very large line sizes. So you can see from these pictures that on the paint stock, it's quite large. It's few meters in diameter, and you can see the size of the guy and the size of the pipe is very big. And in Slovakia, you have those type of plants for your power generation. So this is something for you to think of. This one, the two on the left are from geothermal. So it's brine, because when you have wells to get out the steam. You get the steam, but you get also some brine. And then you need to treat and re-inject and so on. So brine, we do the measurements because most of the time people are using electromagnetic meters, and they have damaged on the liner. And we have also measured with clamp-on from the outside of the pipe there. The one in the center is for steam. Steam measurement is the main production of a geothermal plant that feeds the steam turbine. And the one on the right is for a fossil fuel power gen, where we are using those clamp-on meters on the small lines for lubricating the bearings of the big machines. This one is on a wastewater line. It's interesting, I love this picture, because you see a mag meter, you see a clamp-on, two clamp-on meters. So if you look at the display of one of them, you can see that there's no signal. The mag is defective, but our meters work. And if you look at the screen capture on the signal, it's a fairly old picture. It's the former generation of the portable that Bosch showed earlier. You can see that there's noise a little bit. But what makes Panametrics recognized in the industry is that we can cope even if we have noisy signals. So noisy signals is difficult to handle. You need to get the signal-to-noise ratio within acceptable limits. So it's not ideal, but it does measure. This one is on the FRP, so fiber reinforced plastic. Sometimes you call GRP, so glass reinforced plastic. And very recently, we got also glass reinforced vinyl ester. So these are not easy applications because I'm not sure if you're familiar with it. If you look at the way they build those pipes, they have kind of different layers of those fiberglass, and you might have some entrapped air in between. So the challenge is that if you have too much of entrapped air, it doesn't work. So you need to have a very strong signal treatment and very strong signal to get in to be able to measure. So if you look at this one, it's a fairly large line as well. These are the seawater lines, the cooling water lines, and we see that more and more, not really on the very old plants, but on the new plants we see that a lot because it's cheap and it's light, which means that you can lift that very easily when you do the installation. And clamp-on works. This one is about checking pumps. So there are pumps everywhere. I have a pump at home, right? So if I want to check my circuit, I have a pressure indicator. I guess the same if you have a central heating system. But you don't have any flow measurement. So do you know if your circulator is good as per the spec that you have engraved on the plate? Maybe yes, maybe no. Every kind of pump, centrifugal pump, will have this kind of graph, right? So you have the pump curve, you have the circuit, and you have the maximum efficiency like this, and they should perform within certain specifications. So if you know what the pressure of the head is, you should know from the curve of the pump what is the flow rate. So if you check the flow rate, you can say, yeah, my pump is good, or I might have something wrong with my impeller, I might have something wrong with my bearings, I might have something wrong, I need to investigate. And it's not going to tell you what's wrong. It's going to tell you that your pump is shifting from its original specifications. Okay? So that was just a quick update on some challenging applications we are working. I'm part of the technical advisory committee of the CCUS. We have a joint research program with the SINTEF in Norway. And we try also to innovate a little bit. So as part of the innovation, We have those seal meters I showed earlier on the first slide on refineries. So we were the first company to introduce a seal certified by design ultrasonic. And now we are launching the second gen. It will launch in December of this year. And the difference is that the former version of it had only the certification for fully wetted systems. Now it will also be available with clamp-on, right? So it's been a long journey, I must say, but now we are there. So it can be used with any type of liquid meters, as you can see from the screen. I know I'm kind of on time now. I can open up the floor for questions. I hope my English was not too bad for you to understand me. But in case you have questions, feel free to ask them in Slovak, and hopefully someone can translate.
Dámy a páni, máme nejaké otázky? Nech sa páči. Ak vidíš, že nie, takže Mr. Bottino, thank you very much for your very interesting presentation. Personally, I see a lot of technology that I see in my personal career, and it's very important to see that somebody tried to do the best in the very special condition for these instruments.
Thank you very much.